1.1. This one's generally pretty quick because it's pretty much like an introduction to a lot of things we have already talked about in section 1.2. Alright, so let's start. So I'm going to be writing everything in red, so then just copy down what you guys see in red into your guys' notes. Okay, so the first one is a function is a mathematical relation that maps a set of input values to a set of output values such that each input is mapped to exactly one output value, right? So one input goes to exactly one output. That is what a function is defined. So we're not going to be using the vertical line test to help explain something's a function, but we will be using the statement each input has exactly one output when explaining why a given relation is a function. Okay, so we must connect the inputs and the outputs. So the set of input values of a function is called the domain. The domain. And that's represented by the independent variables, or in other words, the x values, right? So that's the domain, and the set of output values of a function is called the range, which is represented by the dependent variables, or as you guys more familiar know, the y values, right? So you have domain and we have the range. So this is something we have been talking about in class as well. If a function f is positive, that means when the graph of the f lies above the x-axis, the output y values are greater than 0. So remember, if we have a graph, the y values above the x-axis, that is what we call positive, right? And vice versa, the function f is negative when the graph of f lies below the x-axis. The output values are less than 0, or as we know, below the y-axis, right? So if the function is below the y-axis, you guys, that's negative. If it's above the x-axis, then we know it is positive, right? So we're going to be going through multiple representations, whether graphically, analytically, numerically, or verbally. So you guys, to be successful in the AP exam, you gotta know how to go from each one and identify important information no matter what representation you are given. So for this first example, the figure shows an empty vase at time t equals 0. Water begins pouring to the vase at a constant rate until it is full. Which of the following could depict this situation where time in seconds is the independent variable and the height of the water in the vase in inches is the dependent variable? Okay, so here, water is getting poured into this vase, right? Water is getting poured into this vase. Now, it's important to realize, I guess it's more, it makes more sense, you guys, to visualize, does it take a longer time for the water to rise in the vase, or does it take a shorter time? So the way you guys can determine that is by looking at its diameter. So if I were to draw water levels in this vase, right? If I were to draw water levels in this vase. Now, do you guys see how from here to here, the diameters are progressively getting larger, right? So that means as the diameter of this vase, right, as they're getting larger, that means it's taking a slower time for the water to rise, right? Because the wider it is and the wider it becomes, that means the water is slowly rising in the vase, right? But then do you guys see this section where the diameters are progressively getting smaller? So if the diameter or the width of it, right, as it's shrinking, then as the water rises, then the height of the water is just going to increase upward, right? So the water slowly rises first, and then in the second half, then it gets faster, which is represented by letter choice. Actually, think about that and then pick which one, A, B, and C, and D, you think it is. So pause the video and kind of think which letter choice it is based off that explanation. So hopefully you thought about a little bit. Your answer choice should have been D. So the height of the water starts off slower, but then as time goes on, then the height of the water starts to increase more. Okay? All right. So here we have graphical behaviors of functions. So we've been talking about these concepts as well, you guys. As the input value, so this is for increasing. As the input values increase, the output values always increase. So if A is less than B, then f of A is less than f of B. So basically, as you move, if you look with your eyes and you read from left to right, this graph continuously goes upward. So that's an increase. Likewise, if you follow the graph from left to right and it's decreasing and it's going down, then it's decreasing. So this is where the verbiage you guys have to kind of get used to, right? And we've been talking about this. If the rate of change is increasing, meaning as you guys look at these slopes, right? -2, -1, 0, 1, and 2. The slopes are increasing over time. So the slopes are increasing. So whenever you guys see this word of rate of change is increasing, you should always think that that is concave up. Likewise, if the rate of change is decreasing, then if the rate of change is decreasing, then you have to automatically think that it's concave down. So start to get used to that verbiage, you guys. Rate of change is increasing, that's automatically concave up. Rate of change is decreasing, that's automatically concave down. So here are a couple problems to pretty much help you guys out, to help further help you practice what you learn and then put it to the test. So here we have the figure above shows the piecewise function over from the interval from 0 to 9 closed. What are all the intervals where the graph of f is increasing? So this is the graph of f. And if I'm looking towards increasing, I have to look from, when I'm reading it from left to right, when is it going up? That's here. This is going down, so it's not this, and then it's here. So it's in these two sections where if you read the graph from left to right, f is going up. So that would be on the interval. So the graph of f is increasing on the interval or intervals 0 to 3 and 7 to 9 and 7 to 9. Okay, so it's in this section, you guys, and this section. That's where f is increasing. So again, we've been talking about this, but the second thing needs to be clarified is the rate of change. This phrase will be used repeatedly throughout the course. Essentially, the rate of change means the slope, right? Anytime we see the phrase rate of change in this course, we can generally replace it with the word slope to better comprehend. Now, this is important. Ding, 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 ding. This is important for you guys to kind of still marinate in your guys' head, right? We must read carefully in this course. Stating that f is increasing is different than stating the rate of change of f is increasing. So we'll look at these examples, okay? So when I look at this, you guys, first of all, this is the graph of f. So f is positive because everything is above the x-axis, right? Secondly, we know the graph of f is decreasing because as you guys follow this graph from left to right, it is going down. Now, when we look at its rate of change, right, if you guys look at the rate of change, notice that the slopes are progressively getting smaller, which means the rate of change of f the rate of change, I said smaller. The rate of change, the slopes are progressively getting bigger. So that means the rate of change of f is increasing. And we know that because, as you guys can see, if you drew this concavity is concave up. So this is a concave up case because the rate of change is increasing. So again, whenever you guys hear that word, rate of change of f is increasing, you automatically should think the graph of f is concave up. Now, if you guys look over here, if it's below the x-axis, it is negative. If you follow the graph from left to right and it's going up, that is increasing. And again, if you guys look at this, this definitely looks like a graph that is going concave down. This is a part of the graph that's concave down. So as a result, the rate of change of g is decreasing because the graph of g is concave down. So those words are just simultaneous, you guys. Rate of change of g is decreasing, graph of g is concave down. If you see the graph of g is concave down, then that means the rate of change of g is decreasing. They're interchangeable. You have to connect those ideas together. All right, let's look at this. By the way, you guys, this is an AP exam question, and look, this will appear exactly like what you will see on the AP exam. Okay, so let's take a look at this one, right? Okay, so I think what I want you to do is kind of pause the video, process this, and then see if you guys can answer this question just by yourself. Okay, so hopefully you just guessed and see how it looked. So let's take a look at this, right? So the graph of h of t, so you guys, this is the graph of h of t. Oh, but this is the graph of h of t. And its dash midline for 2 cycles is shown. So 5 points, F, G, J, K, and P are labeled on the graph. No scale is indicated and no axis is presented. The t-coordinate of F, okay, this is important. The t-coordinate of F, so this is T1. And the t-coordinate of G, this is T2. On the interval from T1 to T2, which is basically from F to G, which of the following is true about H? So basically, what do we know about going from here to there? Well, first and foremost, it looks like it's decreasing, right? And everything is above the x-axis. So because it's everything above is the x-axis and it's decreasing, your answer choice should have been B. So in this case, H is positive and decreasing. Describe how the rate of change of H is changing on the interval from T1 to T2. Now, if we look at this, you guys, right? We're looking at not the graph of H, we're looking at its rate of change. So if you guys look at its rate of change, look, it's part of a concave down. And if it's part of the concave down, that means the rate of change is decreasing. So here is how you guys write this information, right? So the rate of change of H is decreasing. The rate of change of H is decreasing because the graph of H is concave down. Okay, so whenever they're talking about the rate of change, you guys, then you have to look at the function's graph, its concavity, and that would help you guys out, okay? All right, look at this one. Take your best educated guess, pause the video, and then see how you guys do with this one. Okay, so hopefully guys, you gave it your best shot. So with this one, I'll go a little bit faster. K, it says this one's T1. P, this says it's T2. And then on the interval t1 to t2, which of the following is true about h? So if we take a look, from t1 to t2, it's going up, so so h is increasing, and again, everything, wait, let's see, where is this? Oh, so now look, this is where you gotta be careful. So from t1 to t2, it's increasing, right? It's increasing. Now take a look at this. Look at all the y coordinates, you guys. Do you notice the y coordinates are all negative? So that means this is all below the x-axis. So as a result, h is negative. So h is negative because everything is below the x-axis by looking at the y coordinates, right? And then it's increasing because from t1 to t2, or from k to p, it's going up. So that would be C. Now describe how the rate of change of h is changing on this interval. Well, if we look at this again, right, this is concave down, which means the rate of change of h is decreasing. So basically, this is the exact same explanation as we did before. So I'm just gonna copy and paste this over, and you guys should literally write this too, because you guys gotta get used to writing this. The rate of change of h is decreasing because the graph of h is concave down, okay? All right, let's look at this. So I think examples 5 through 12, these are something for you guys to exercise and practice, but I suggest you guys give it a shot first from 5 through 12, and then pause this video and see how you guys do, and then I'll reveal the answers. Okay, so again, this is just more practice time for you guys more than anything, all right? So it says, on which of the following intervals is k negative and decreasing? So k is negative and decreasing. So basically, we need to see where k is below the x-axis and where it's going down. Well, so we can only look here and here, but this is increasing, so no. This looks good, right? It's below the x-axis and it's going down. So that means it would be letter choice C, from D to E. Let's see. Okay, here. Which of the following statements about the rate of change of k is true? The rate of change of k is negative on the interval from A to B. So the rate of change is negative, which means it's got its negative slope. So from A to B, does this have a negative slope? Nope. This has a positive slope. So it can't be this one. The rate of change of k is negative on the interval from B to C. Well, this rate of change, the slope, you guys, is positive, so that's another no. The rate of change of k is positive on the interval from D to E. So if we look from D to E, guys, if we draw a tangent line slope, that's negative, so that can't be it. So the answer choice must be D. The rate of change of k is positive on the interval from E to F. So if we look at the slope here, the rate of change, right? It's a positive slope. So that answer is D. Which of the following is about this rate of change of k is true? So this is talking about the rate of change of k is decreasing or increasing, basically. So if we take a look at this, your answer choice should have been letter C. The rate of change of k is increasing from D to E. Now, is that true? This is concave up, which means the rate of change of k is increasing because it's concave up. So that's why that one's true, because it says for D to E, it is true. Okay? So hopefully that was some good explanations of that. Oh, we have one more. Example 8. So for example 8, the answer choice is B. on which of the following intervals is k increasing and the graph of k is concave down? Increasing and it's concave down. So that's the interval from B to C, okay? All right, so we're going to here. The following shows the graph of f. On which interval is f decreasing? So here, f is decreasing on, it's only from here, you guys. From here to there. So that's from -1 to 2. -1 to 2, okay? On which interval is f both negative and increasing? So negative has to be below the x-axis and it has to be going up. So this one's from -5 to -3, okay? -5 to -3. This one, here's a graph of g. This is the last bit of notes, you guys. On what interval is g decreasing and the graph of g is concave up? So where is g decreasing and the graph of g is concave up? So it definitely looks like it's decreasing from here to here, you guys. But which section is also concave up, and it's here, right? So this is the overlap. So it's from -1 to 1. -1 to 1. Decreasing, and it's part of the concave up, right? Part of the happy phase. And lastly, on what interval is the rate of change of g positive and decreasing? So, okay, so first, the rate of change is positive, right? So that means the slopes are positive. So where does that occur? Well, those occur there. So in that region, that's all positive slopes. And from here to here, that's all positive slopes. Now, amongst these two, which one is the rate of change of g decreasing? The rate of change of g decreasing, not the graph of g is decreasing, the rate of change of g is decreasing, which is where it's concave down. It'd be this section. So basically, that would be -5 to -3. And you could put a bracket here too, -5 to -3. Okay, so hopefully these notes help you. So yeah, follow along, and then you guys have a homework assignment on this as well. Okay, hopefully this was helpful. Good luck to you all. Peace.